Hi, Ms. Escobar. Hi, Ms. T. I have here a worksheet for students for their week one of their 5 weeks of chemistry. This worksheet would cover day one and possibly day two if you run out of time. I have here a lesson document for the teacher. This lesson document would cover the entire week, the week being a week of 3 days of science. Now, the first part of this week, first day or 2 days, consists of students working online with the PhET simulations, PhET. The second part of this lesson consists of hands-on experiments, and this would be day 2 or day 3, depending on how long the PhET takes. In the hands-on experiments, you will be using materials which we will provide. I will bring to Mr. T mixtures of sand, salt, and iron filings. I'll bring 15 little bottles of those mixtures so students can work in groups of 2 or groups of whatever size you like. Actually, if I bring 15, students would have to work in groups of 4, so I'll have to bring 30 to give you the option of letting students work in groups of 2. I'll also bring beakers that students could heat up and hot plates that students could heat them up on. I don't have enough hot plates for students to work in groups of 2 since you have more than 30 students, but if you want students to work in pairs, more than one group can share the same hot plate. Now, I'll make a separate video for the hands-on experiments, but for day 1 and possibly day 2 if you run out of time, what students will need is computers with a modern browser. So the PhET is accessible like this. You're going to have to show the students how to access this. It's phet.colorado.edu, and then they have to search here for the States of Matter game or simulation. I could also find it by clicking on Play with Simulations, but I think it's just faster to just type States of Matter there. The one we're looking for is Basics HTML5. Basics is important because it only has 2 games, whereas the regular States of Matter has 3 games, and we're not going to use the third game. HTML5 is important because if you use the other kind, you have to download Java, which takes a long time. HTML5 does not require any downloads, and students will work with the first game here. There are 2 games available. I don't have students working with the second game in the worksheets, but I think it's important that the teacher show the students, or perhaps even have the students play with the second game, and I'll show why in a moment. The first game looks like this. There's a container. There's a thermometer. Students should change this to Celsius immediately so that they could work with something that they're a little bit more familiar with than Kelvin. There are 4 different substances. Students should try all 4 substances just for fun, just to see what happens. And there are 3 states of matter. The questions in the worksheet are related to these 3 states of matter. For each state of matter, students should try to change that state by cooling the stuff down or by heating the stuff up. Right? I have a separate question in the worksheet about that. Let me now show you the worksheet. So here, students need a definition of matter that they get from the textbook or from the teacher, preferably from the teacher because the teacher could give examples and run a little discussion in the class to eventually come to the conclusion that everything that you see in the universe, which is tangible, which you could weigh on a scale, would be matter, including air. Here, matter is made of atoms and molecules. Students are going to need to know that from the teacher or from the textbook, preferably from the teacher, I think, because I don't know that your particular textbook would give a statement like this that is easy to find. But I think that part where the teacher needs to tell the students these answers should only take about 10 minutes or less. Most of the class time for this should be occupied by students playing with the PhET, playing with the solid, the liquid, and the gas, and the students need to describe each state of matter in 3 ways, and they have to use these words. They're going to have trouble using these words, so I think this teacher has to maybe even do the first one for them. What I'm trying to get here is I'm trying to get the students to come to the realization that is outlined in this particular performance expectation, MSPS14, and I'm trying to get the students to hit these parts of the DCI, changes of state, and what the particles are doing in a solid, liquid, and a gas. So here's what the teacher has to go around and make sure, here's what the teacher has to go around and make sure the students realize. Students need to realize that the solid, let's go for a simpler solid. The solid keeps its own shape and its own volume. The particles do not fill the whole container. They're always touching each other. The liquid, particles are touching each other, but they do not fill the whole container. And they do not have their own shape. The shape was boxy, but now it's not boxy. That's a liquid. These particles move around, they slide by each other. And in a gas, the particles do not keep their own shape and they do not keep their own volume. They fill the whole container. If it's hard for students to get to the idea that particles fill the whole container, that's when you use the second game in the PhET. Remember, there were two games. Here, let me show you whether there were two games. So this PhET has two games. If it's hard for the students to realize that particles of a gas do not keep their own shape, you do the second game. And in the second game, you can heat something up so it becomes a gas. And you can mouse over the finger, and when the green arrows appear, you can compress. You can change the volume of the container. So if I make these particles into a gas, and then I increase the size of their container, notice that they take up eventually the entire container. But a liquid won't do that. So if I drag the container down to a smaller size, and then I cool the matter down so that it becomes a solid or a liquid, I should probably change the temperature to Celsius so it's easier to understand. I cool the matter down so it becomes a liquid or a solid so that all the particles touch. Then when I open the container up to a larger size, the particles don't care. They keep their same shape, they keep their same size. If this is a liquid, I think this is a liquid at this point, they don't keep their own shape, but they keep their own size. Eventually, this is going to become a solid because it's really cold. Okay, so that is important, and that's just another tool that the teacher has to show the kids that concept of changes in volume. Now, next I have the students playing on this worksheet with the heat. So they need to know that to change the solid or liquid or gas, all they got to do, if it's solid, all they got to do is increase the temperature. And eventually it's going to change to liquid. Now, the point at which it changes to liquid is kind of a judgment call because there's no way for the students to tip over this container to see if the stuff flows. There's no way for students to put something into this container to see if they could stir it the way you would stir a liquid. So is this a solid or a liquid? This is a judgment call for the students. There is wiggle room and there's room for discussion. Those discussions that students have with each other or that the teacher has with the class are valuable because important concepts are bandied around. The concept that these particles are in motion and they're not keeping the same positions, that suggests that this is a liquid. However, a few seconds before this point, I was just talking, and for a few seconds before this point, this stuff, all these particles, they had their own shape. They were moving around, but they were being held into roughly the same blob, and that is more like a solid. And so an argument is possible here. There isn't necessarily a right or wrong answer as to whether what we're looking at here right now is a liquid or a solid at any given moment. And that's because this is a game. You can't do other experiments on this. You could just watch the molecules, right? So that kind of debate is valuable for helping the kids to reach these DCIs and the performance expectation up here. changes in particle motion temperature of a state. Now, here, this second page of the worksheet is my attempt to get the kids at a place in their brains where they're going to understand the hands-on work for the next day of this lesson. So in the hands-on work, they're going to separate sand from salt from uh, from iron filings. So a mixture of sand, salt, and iron filings. They'll remove the iron filings with a magnet, but they'll remove the sand from the salt by mixing with water and filtering out the water and the salt, and then boiling off the water to separate the salt. That last part is hard to understand. Many students believe, even in 8th grade, that if you boil salty water, the salty water boils off. But that's not true. If there's enough salt in that water, you'll be able to see the solid salt. We tried this last year at DVS, but we couldn't see the salt because we were boiling tap water. Sorry about that. But if we add water in, if we add salt intentionally to the water, we'll be able to see the salt after the water boils off. So the second page of the worksheet, I want students to understand that if you have two different substances and you boil off one substance, you're going to be able to separate those two substances. So here I have oxygen and I have water. I ask them to open two FETs, two games. So here's oxygen. I asked them to open this at negative 116 degrees Celsius. So here it is, negative 116 degrees Celsius. I asked them to open water also at negative 116 degrees Celsius. So let me get this. Here it is. Water at negative 116 degrees Celsius. So they can compare these two, and if they have enough time to wait, they'll notice that at negative 116 degrees Celsius, you have a lot of gas here. But at negative 116 degrees Celsius, this is all solid. There are two different states here. If you have a mixture of this and this at the same temperature, you're going to have two separate states. You're going to have a solid state and you're going to have a liquid state. And that's what I asked them in this second page. So this second page is going to require the students to look up some melting points and some freezing points of water and oxygen and of salt. Because at the end here, I asked them to do the same thinking behind this observation, but to do it with salt and water and not oxygen and water. So salt is not available here. So this is going to require some imagination on the part of the kids. What would happen if I mix salt and water? The answer, of course, is that at negative 116 degrees Celsius, I'm sorry, not negative 116 degrees Celsius. So at 125, so I ask at 125 degrees Celsius, the answer is, of course, that if you take water to 125 degrees Celsius, you're going to end up with water gas eventually. So at 125 degrees Celsius, you're going to end up eventually with water gas. But the salt is going to remain, so they don't have a way of doing this on the game, but they need to be able to think that although the water is going to rapidly become a gas, the salt is going to remain a solid because the melting point of salt is very high, and they'll find on the internet it's something like 800 degrees Celsius. That's it. That's their worksheet that I have for you for day one. It could move into day two if the discussions take a long time. Let me know when you're done with this, and I will bring the materials for the hands-on portion, the mixtures, separation of mixtures, to Mr. T. Thank you.